This video covers Section 8.6, Compound Inequalities, Objective 3, Solve Compound Inequalities involving OR. The solution to compound inequalities involving the word OR is the union of the solutions to each inequality. And is intersection. OR is union. So we will solve each inequality separately and find the union of the solution sets of each inequality. 3x plus 1 is less than or equal to 4, or 2x minus 3 is greater than 9. 3x plus 1 is less than or equal to 4 says that 3x is less than or equal to 3 by subtracting 1 from both sides. Dividing both sides by 3, we get x is less than or equal to 1. Or 2x minus 3 is greater than 9. We add 3 to both sides. And it says that 2x is greater than 12. Dividing both sides by 2 gives us x is greater than 6. So either x is less than or equal to 1, or x is greater than 6. Less than or equal to 1 is all the numbers less than 1 and including 1, or x is greater than 6. So we have to put these two sets together. The union puts the two sets together. And so the set builder notation is the set of x such that there's no compact way to write this anymore. It's x is less than or equal to 1, or x is greater than 6. In interval notation, we have to have these two disjoint intervals written, negative infinity to 1, including 1, and union, or put the two sets together, from 6 to infinity. And this leads me to practice 5 for you to try. I encourage you to press pause on your video and work this out and come back when you're ready to see the solution. So to solve the first one, 3/2 times x plus 4 is less than 6. Let's multiply both sides by this reciprocal first and get x plus 4 is less than 3 goes to 6 twice, and 2 times 2 is 4. And then subtract 4 from both sides and get x is less than 0. Doing that same thing on this one, 3/2 times x plus 1 is greater than 15. Multiply both sides by 2/3. And get x plus 1 is greater than 10. Subtracting 1 from both sides gives us x is greater than 9. So this is the union of these two sets, so we put them together. Less than 0, greater than 9. And so in our set builder notation, we have the set of x such that x is less than 0, or x is greater than 9. In interval notation, we have the two disjoint intervals, negative infinity to 0, union 9 to infinity. Practice 6 is for you to try. This is that compact notation. So this means that it's no longer an or, it is an and. So this will be an intersection. So I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. Let's multiply both sides of this inequality by 3. And that'll give us negative 12. The 3's will cancel. And 3 times 3 is 9. We'll clear that 3 in the denominator. And so now we'll solve this by adding 3 to both sides. 9 plus 3 is 12. And negative 12 plus 3 is negative 9. Getting rid of the 4 in the middle, we have divide by 4, divide by 4. That's x is less than 3, greater than or equal to negative 9/4. So this is the and, or the intersection of two sets. So it's less than 3, greater than or equal to negative 2.25. In set builder notation, this is the set of x such that x is greater than or equal to negative 9/4 and less than 3. And in interval notation, the left side is negative 9/4 and the right side is 3. And again, notice that in the or statements, there is no way to write this compact notation like there was with the ands. And that's what this work smart statement is saying. If you have x is less than 1 or x is greater than 4, it is not correct to write it in that compact notation. There are no real numbers that are less than 1 and greater than 4. And another common error is to mix symbols, as in x is greater than 1 and x is greater than 4. This notation makes no sense. And the last note, remember that intersection means what they have in common. So what they both have would be and union is if one has it or the other one has it, then it goes in the union. And this concludes the video for section 8.6, compound inequalities. Objective 3, solve compound inequalities involving or.